Subscribe to Emmanuel tutorials and press the bell icon for notifications.
Hello everyone, welcome to Emmanuel tutorials. Today in this class we would be studying about the different operators that are used in Python. The very first category of operators are the arithmetic operators. The arithmetic operators in Python are just like the ones that we use in other languages like C, C++ and Java. So we'll just go through it once. In case I have two variables A and B, A stores 10 and B stores 20. So the different, if we wish to add both these numbers, we simply have to use the plus operator. We can see the output as 30, which is 10 plus 20. Similarly, if we want to subtract the two numbers, we simply have to use the minus sign, which would give us the subtracted output. 10 minus 20 is minus 10. If we wish to multiply both the numbers, we can use the asterisk sign, and here we can see the output as 10 into 20, which is equal to 200. Similarly, if we want to divide, now Python provides us two different kinds of division. One is the normal division that we perform, and the other one is flow division. First we'll see the normal division, for which we use the slash. So it will give the result as 10 divided by 20, which is equal to 0.5. Now there is something known as flow division in Python, which are two backslashes. If we evaluate it, it will give us the answer as 0, which means it gives us the flowed output. We'll take some other numbers and try the same thing. If I take 40 and if I take 15, now the result of this expression would come in decimals, but when we use the flow division, we'll get the result as 2 because it doesn't consider any digits after the decimal point. It gives us the lower number. Now we can try the same example by considering the numerator as a negative number, which would slightly change the result. Now here we can see it's giving us minus 3 because when we consider the number line, the lower number in the number line is minus 3 and not minus 2. So the result in this case is minus 3. The other operator is mod, which will give us the remainder. Just as in other languages, we simply have to put the percentage sign here. 40, when we divide it by 15, the remainder is 10, and the answer here is evaluating to 10 as expected. Now if we wish to take the power of a number, we'll take some smaller numbers for this. The operator that is used in Python are these two asterisk signs, which means A raised to B. So the result is 3 raised to 4, which is 81. Now these are all the arithmetic operators that we use in Python. The next one, we'll see the logical operators. Python provides us with three logical operators. One is AND, one is OR, and one is NOT. And they just mean the same thing as in the other languages. We'll take two variables again, one holding true and one holding false. In Python, true or false values must be written as true or false with T and F capital, as we saw in the previous video. Now if we want to check it, we simply have to do, now true and false means false, so we'll verify the answer if A and B. Print maybe we'll simply print a message here. In this case, it won't print any message because true and false is false, so the condition in the if statement is false, so it won't go within the if statement. At the same time, if I change this false to true, true and true is true, so it will give us the output as hello. Now the same thing we can verify it with the OR operator also. Now true or false is true, so it should give us the output as hello, and here we can see the output which is coming as hello. Now the last operator is the not operator in the logical category. So we simply have to write if not space the variable name to verify it. So a is true, not of true is false. It will simply complement the value. So in this case also it won't give us the output because not of true is false. At the same time, if I replace a with b, because b is holding false, not of false is true, so it will give us the output. We can try running it, and here we have the output as hello. These are the logical operators in Python. The next category of operators that we'll be seeing, these are the relational operators. Now relational operators are also the same as we use in other languages like C, C++ and Java. We'll check it. Now here also we can take maybe two numbers, a equal to 10 and b equal to 20. Relational operators are also known as comparison operators. The reason is because we try to compare two values and identify the relation between them. So the first one we'll check for the equal to operator. Now the equal to operator simply checks whether the LHS and the RHS, if both of them are equal. In this case a is 10 and b is 20, so a is not equal to b. Sorry, there was an error there. If a equal to b, it will print the message as equal. In this case it won't print the output because they are two different values. At the same time, if I change the value, here we can see it's printing the output as equal because we have changed the values. Now the next operator is the not equal to operator. To verify the answer, I've changed the value again. I've taken two different variables which hold 10 and 20. Now here we can change the message as not equal, and here we can see it's giving us the output as not equal because both of them, the values are different. Now the next operator is the lesser than operator, which is this opening angular bracket, and we can simply print a message lesser. So this will so in this case it will print lesser because 10 is lesser than 20. Now in case if we wish to check whether the two variables are less or equal, we can use the same thing. I've taken the same values here, and the lesser than equal to operator is written like this, the opening angular bracket and the equal to sign. Here we can change the message as greater. Now 10 is lesser than equal to 10, so it is printing the message as lesser or equal. Now if I change the value, we can verify the answer. Here it is printing the output as greater because 30 is greater than b, so the condition in the if statement becomes false. The same thing for the greater than equal to operator. Simply use the closing angular bracket and use the equal to sign. This message we'll just change it. Now if we see the output, it is giving the output as greater or equal because 30 is greater than 20. Now these were the different comparison operators that we have in Python. The next one we'll be seeing the assignment operator. In terms of assignment, the equal to sign that we have been using in the previous parts of code is the assignment operator. So in this example we are assigning the value 30 to the variable a, and so this equal to is the assignment operators. In we can also have a compound operator, something like a plus equal to, and anything, maybe simply just a value I will take. So what does this mean? This is equivalent to first adding up the numbers, so this what we have written here, a plus equal to 30, it is equivalent to writing a equal to a plus 30. So if we see the output, we'll print a first. You can see that first it is printing 30, and in the next case it is adding 30 to the previous value of a, and then again assigning the same result to the same variable a. So if we see, the output is coming to 60. Now the same way as we have done plus equal to, we can have minus equal to. So initially we had the variable a storing 30, it printed the value as 30. Now 30 is being subtracted from a and then being assigned back into a. So the result is 30 minus 30, which is 0. I'll just take some. We can have the same thing for multiplication as well. If we run it, initially it printed the value of a as 40. Now it has performed the operation as a into 30, which is 40 into 30, which is 1200, and it has assigned it to a and printed the output. So we can see the output is coming as 1200. And the same thing applies to the other ones as well. We can use it for division also. The result is 40 divided by 30, which is 1.33. Now this was the assignment operator, and the way you can combine it to form the compound operators. Now next we would be looking at the bitwise operators in Python. Now bitwise operators, they work on individual bits, that means on 0 and 1. So we have different bitwise operators. We have the AND operator, the NOT operator. So these are the different bitwise operator. We'll see the output. Now in case I store the value 10 into a, if we consider the binary value of 10, it is 1010. Similarly, I take another variable which stores the value 20. The binary of b is 10100. Now whenever we try to obtain the result of these bitwise operators, we need to consider the 8-bit binary value. So I am simply converting it to 8-bit. So these are the binary values. Now we can check the operation. If we do c equal to a and b, now what happens here is each individual bit starting from the LSB is ANDed with each individual bit of the b variable. That means in this case 0 and 0 gets ANDed. 0 and 0 is 0, so the result would be 0. Similarly for the other bits. So if we try to print the value of c, we can try evaluating the result here. So 0 and 0 is 0, similarly evaluated for the other bits. So the answer a and b must give 0. So we'll try running the code. So we can see the output is coming to be 0. Now similarly we can use the OR operator. OR will give 1 for all cases except when both the bits are 0. So here 0 and 0, 0 or 0 is 0. Similarly 0 and 1, 0 or 1 is 1. So we can try it. So this is the binary value. So now if we try to print it, it is giving us 30, which is the decimal for this binary value. Now the same thing works with the XOR also. We can try to print the result. We can try to print the result here. So it is giving us the answer as 30 because 0 XOR 0 is 0, and for the other bits, for dissimilar bits, the result is always 1. So here we have 1. Similarly, this 0 XOR 1 is 1, and the remaining bits it will be 0. This is the binary for the decimal 30. So we have got the answer as 30. Now we have the negation operator or the complement. It performs the bitwise complement. For this we require only a single operand. So we can do A. So what this operator will do is it will negate each individual bit. So if we try to negate the value of this binary, the complement of 0 is 1. Similarly 1 for all of this, and here it would be 0 1 0 1. Now since the MSB is 1, we know that it's a negative number. So if we run it, we get the answer as minus 11, for which the binary is 4 times 1 0 1 0 1. This is the way we use the bitwise operator. Similarly, we have the left shift and right shift operator. Now for this, in case I take the value as 30, and if I take the variable C as A and I want to shift it to the left by 2 bits. Now how is this operator used? We simply specify the value or the variable in which the value is stored. We put the operator. The left shift in operator is given by 2 opening angular brackets, and then we have the number of bits by which we wish to shift the binary value. In this case I want to shift it by 2 bits, so I mentioned 2, and the result is getting stored in the variable C. So, or maybe we can take a smaller number just to verify the result. So I have taken it as 10. Now if we see the output, it is 40. So after shifting, this is the answer that we get. These 2 bits are dropped off. We have the remaining 6 bits in the answer as it is, 0 0 1 0 1 0, and finally towards the right hand side we append zeros based on the number of bits by which we shift, and this is the binary for the decimal value 40. Similarly, we can do the same thing for right shift as well, and accordingly see the output, and the result is 2 because we can verify the answer as well. Now when we shift it by 2 bits, these 2 bits are dropped off, so what is left, since we are shifting it by 2 bits, we'll have to add 2 zeros and then copy the bits as it is. Now this is the binary. These 2 bits are gone. Have the remaining bits as it is by adding 2 zeros towards the beginning. So the result is 2. Now these were the bitwise operators. Now we would be looking at 2 categories of operators. One is the membership operators. Now membership operators in Python, they simply check if a specific element is a member of some data type or data structure. We'll take the example of a list in Python. Lists in Pythons are written using these square brackets. In case I have a list of these numbers, maybe with these 4 integers, now I wish to check if the number 1 is a member of the list L1. So the membership operators in Python, they are given by in and not in. So if I wish to check if it is a member, I can use the if statement. If I wish to check if 3 is a member of L1, so I'll write if 3 in L1, and I can print a message member, or maybe present, else print absent. Now we can try running it also. It is showing present because the number 3 is present in the list L1. Now if I check for a value which is not present, maybe some 34, so if I run it, it will show absent because it is not present. Now I can do the same thing for strings as well. If I have a string hello, and if I wish to check if the character A is present in L1, it will show absent because the character A is not present in this string. And if I check it for H, it will show me that it is present. So this is the way we use the in operator, and for not in also it's the same thing. I can check it for another character. Now A, now we are checking if A is not in L1, so it is showing it is not present because the character A isn't present. Similarly, you can check it for some character which is present also. Now it is giving if L not in L1, it would print not present, but since it is present, it is giving the output as not absent, which means present. Now the last category of operators is the identity operators. Now these identity operators, they are used to compare the memory locations of two objects, or to simply check the value of two individual objects that we have. In case I have a variable A which is storing the value none, or maybe we can take a string here which is storing hello, and similarly I have another string which is storing the value hello again. So I can check it by using if A is B, print equal. Now it will give me the output as equal. If I change even a single character, they point to two different memory locations. Maybe we can put the else part here. So it will give us the output as not equal. And the part of is operator is the is not operator. Now here also we can check for the same thing. It will print not equal because these are two different two different objects, and they point to two different memory locations. So these are the two identity operators, which are is and is not. So we have, in this class, we have seen the different operators that are being used in Python, which are the arithmetic operators, the relational operators, the logical operators, the assignment, bitwise, membership, and identity operators. In our next class, we would be looking at some higher level concepts in Python, like the iterative constructs and the conditional constructs and all. Hope you all liked this video. Do subscribe to the channel for more. Thank you.
Subscribe to Emmanuel Tutorials and press the bell icon for notifications.